Eric.
Hey Charles, how are you doing?
Great, man. We're laying that next rocks.
Yes.
Yes.
What's going on?
Wonderful.
Okay, so here we are with kind of, with three academics. Clemens Spersky,
Indeed.
Carl Hewitt.
Yep.
And
Hello.
what we're going to do is we're going to talk today about actors. Everything you always wanted to know about actors, but were afraid to ask.
Excellent.
We can now ask the questions to the guy that invented actors.
Yes.
Because actors, people talk about actors here, actors there, but they use it in a very informal sense.
Right.
But Carl has, has a very kind of, precise meaning of what an actor is, and that's what we're going to kind of, suck out of his brain today. And Clemens is going to help me with that.
We'll suck.
Yes.
That's right.
Okay.
You do a good job of it,
Yes.
too.
Right on.
So Carl, what is an actor? It's not somebody that's kind of is in a TV show or like us right now,
No,
right?
no. The actor is the fundamental unit of computation. As the fundamental unit of computation, it has to embody three things.
Okay.
It has to embody processing, because you've got to get something done.
Okay.
It has to embody storage, because you have to be able to remember things and store things, and it has to be able to embody communications. So an actor is the fundamental unit, the primitive unit, that embodies all three essential elements of computation.
I made a mistake here, sorry.
Okay?
I started to count with one.
Yes.
Okay.
You're getting old.
Yes,
Okay.
too long out of the Netherlands, it's like Dijkstra is kind of, yeah. So now, okay, so this is great. So an actor embodies these three things. Now,
Yes.
people often kind of, when they talk about actors, they talk about like, mailboxes and message queues and concurrency and locks. And so, how does that fit into this picture?
Right, that's a very good question. The first thing is that we have to be reminiscent of E.O. Wilson. E.O. Wilson famously said that one ant is no ant, right? Well, one actor is no actor. They come in systems.
Yep.
And so in order to come in systems, they have to have addresses. So
Okay.
that one actor can send a message to another actor, and there's no reason an actor like Factorial can't have an address for itself. So that's the way you implement recursion.
Okay.
Okay. But then the actors are very abstract, because beyond this, okay, all we have is certain fundamental properties of actors. For example, suppose the first property is that everything is an actor.
Okay.
And then you say, an actor has a mailbox. Well, a mailbox is an actor, so now the mailbox needs a mailbox.
Yep. Yes.
This
Okay.
is a disaster.
Yes, so now we're going down the rabbit
We're
hole.
down the rabbit hole, that's right. Right.
So where does the recursion end?
With the axioms.
Okay, good. Axioms. I love
That's
that.
right, yes.
I love
Okay.
axioms.
Very solid.
Yes.
Yes. So what are the axioms
The
of
first
actors?
axiom is when an actor receives a message, okay.
Now I'm using kind of,
Yes.
axioms. I'm using
Axioms,
kind of,
that's right, yeah.
Roman numerals
What
for
can
that.
it do? All it can do is it can create some more actors. It can send messages to actors that it has addresses before. And it can designate what it's going to do with the next message it receives. And that's it. Everything else has to be done out of that.
Okay, so the third thing again? Just
The third thing is you designate how you're going to handle the next message you receive.
Okay, good. Does that something to do with continuations?
Well, no, because continuation was an old idea for the von Neumann machine.
Okay.
Continuation is the lambda expression that you execute after you finish doing the current one.
Okay.
So that's a single-threaded kind of idea.
Okay. So this
Whereas this has to do with concurrency.
See?
If you're a checking account, right, and you have a balance of $5, you might receive a deposit message with $6. Now your balance is $11,
Yeah.
right? So you say, when I process the next message, I process it with a balance of $11.
Okay.
I don't change any of the names I have now. The change applies to the next message that comes in.
Okay. So then I have like a clarifying question. So here you say that, so because here it says, you kind of, decide or designate what you do with the next message, but this message loop here,
No
right?
loop.
Or there's no loop, but where is the kind of, can an actor do many things in parallel, or can it only kind of, send messages to the other ones, create new ones, and kind of,
Okay.
in
Nominally, the first approximation, it processes as one message at a time.
Okay.
But the implementers know how to pipeline messages in certain cases, and in the case when you're going to process the next message in exactly the same way you're processing the current message, somebody like factorial,
Yep.
you can do all of them at the same time. So factorial can be processing arbitrarily many messages at the same time.
But conceptually, you kind of you process one message at a time, and
That's
then
right.
the implementation can kind of make that more concurrent.
Yeah, that's right. Yes.
Okay, so is that okay if I kind of write that down? Because
Sure.
I'm looking
Right,
for the
yes,
conceptual
the
model,
conceptual
right?
model, that's
yes,
right,
so
yes,
we were
yeah, it
looking
is.
for the conceptual model. So conceptually, okay. So now, of course, the question
And you
is.
put an asterisk on that because the loopholes are large.
Okay, so I'll
Quote, yes, right.
quote it like that. So now the question is, what happens if an actor sends a message to itself? Maybe directly or indirectly. Would it go into a deadlock?
Well, okay. The next thing
Yes.
you have is the notion of a future.
Okay, good. So, future. We all have a future.
We all have we hope, right? The idea of a future
Okay.
is that you can create an actor for any result while it's still being computed. You don't know whether it's finished computed or starting or whatever, but you can now have an address for something. Like when you buy a future for a bushel of wheat, okay?
Yes.
Then it's for a bushel of wheat not now, but in the future, okay? And if a drought happens, then the future will break, and you will get an exception instead of a bushel of wheat. Well, these
Okay.
futures are the same way. But they are actors, you pass them around. So, for example, you say, future of factorial of 100 million, and you think it might take a long time to compute the factorial of 100 million, but you get the future immediately.
Okay.
And you can pass it around, and you can store it, and you can send it in messages. So now, if you want to send yourself a message, right?
Back.
You can put the message to be sent to yourself in this future, send it to yourself, and now you don't deadlock.
Okay. Good. All right. So that sounds good. So Clemens.
Yes,
Yes.
I'm wondering
Yeah.
if we designate what